So is everyone up and connected to the internet? Everyone's got a board, pizza and beer, the really important parts? All right.
I don't have a really cool looking bow tie though.
It comes with time. So we're going to be going over BLE Advanced today. Last month we covered the basics of BLE. Can I get a show of hands for who was here last month? Awesome. Now, who of you actually remember what we talked about? Okay, that's about what I thought. So, in case y'all have totally forgotten, there are two main parts to BLE. There's GAP, Generic Access Profile, and GAT, Generic Attribute. GAP is for advertising. It goes 1 to many, and it has a very small payload, usually about 26 bytes effectively after all the overhead happens. GAT is a session version of the protocol. It talks 1-to-1, and you can transfer much larger quantities of data and usually multiple quantities of data. We are going to cover how to make custom services with each of those today. So we're going to go into how to use the GAP layer to send custom formatted data across it and how to receive it on both ends. We're also going to cover that with GAT. Honestly, I don't think you're going to use much of the GAP customization. You're going to probably use the GAP customization, so that's the T one. And we'll go into that. Before each section, I'm going to go over what it was last month so that you have some idea where we are. I'm going to go into how to customize it using the mbed platform. If we have time tonight, I'm going to get into a wonderful thing called Evothings, which is essentially a way to write smartphone applications in JavaScript. That's why you'll see on both iOS and Android the Evothings client application. If you'll go ahead and download that in advance, it can be a little bit big and the Wi-Fi here can be a little bit shoddy at times, so give it a nice long stretch to get going. Also make sure if you've got iOS that you've got Light Blue installed. And if you've got Android, you've got the NRF Master Control Panel installed. We're going to use these to interrogate our devices before we get to Evothings. So I'll show you both how to use BLE with generic apps and with the custom app you'll be writing yourself. Questions, thoughts, concerns, deep philosophical impediments? All right. Now, before I get to all that, I have to advertise we're going to be at South by Korean next week. That's Friday, Saturday, Sunday. We're going to be in the free part of it. If you want to come by and check out the stuff we've got a lot of cool demos. Oh, including a connected coffee maker. It'll tell the internet what color capsule and how much you drank. Because you really want your doctor to know how much caffeine intake you have. All right, so that's what we're going to do. Usual format. We're going to try and walk y'all through it as best I can, and then we're going to workshop on it for an hour. So, yeah. Generic access profile. It's the 1 to many. It's essentially a broadcast, like a really small child yelling really loud in a crowded room. Everyone can kind of hear them. Not necessarily everyone wants to listen to them. It's how you advertise your presence to the rest of the world. GAP is the advertising layer of BLE, and it is the way that you first initiate contact before anything else happens. Everything happens like that. That said, to be low power and Bluetooth low energy, you have to keep your packet size small. So the effective transfer size of any any GAP packet is about 26 bytes. It actually starts out as 47, but due to other things, it gets knocked down to you have 26 bytes of custom data you can play with. So in case you've forgotten, that 47 bytes gets broken down as follows. There's actually an extra little bit, so it's really 39 bytes that you care about. In case you've forgotten, this section right here is where it actually gets interesting. This is 31 bytes. Inside of this 31 byte area, you can have multiple different data structures. Each data structure that you have has 2 bytes of overhead. There's also one required data structure that is the flags, so that you can tell them, hey, I'm not connectable or I'm connectable, and I am low energy only or not low energy only, et cetera, et cetera. So one structure is given the flags. That means 2 bytes of overhead plus 1 byte of payload, that's 3 bytes. So 3 bytes of that 31 are immediately taken away for flags. And then you have one more structure you can use. That structure will have 2 bytes of overhead. That means of that 31 bytes, you've lost 5 bytes right out of the gate. 31 minus 5 is 26. And there we are. You have 26 bytes of data to play with. Oh, hey, I just did math. Awesome. So again, 26 bytes. That's a really important number to remember. 26 bytes for GAP. Okay, so if everyone would go to this shortened web address, it's going to take you to an embed code page. That code page is going to contain some code that I hacked together this afternoon, and it is going to demonstrate how to use custom gap. So when you get there, do the usual embed thing, add it to your compiler. Before you compile it and download it to your board, make sure you add a name. You'll see these two lines up here. You'll need to uncomment them and give your device a name. Right here where the arrow cursor is, you'll see change me is the current name. Change it to something else, otherwise we'll see 50 different change me's pop up and no one will know who anyone else's device is. If you have questions, concerns, raise your hand. I've got 3 awesome engineers in the room who are going to be able to walk around and help out.
What is this device to add on to my?
That is the InterFD case. If you go to the platform section. Does anyone not remember how to use embed? Cool.
So you uncomment the line and change the name.
Yeah, you uncomment 2 lines. The reason I'm having you uncomment these 2 lines is because you don't have to have a name in gap. It's not required. If you don't have it, it'll still work. You just won't be able to find your thing because you don't speak machine. So we're adding a name to make it human friendly. I wanted to make sure that y'all got that point. So I'm commenting it out by default and having you add it in to drive home the point of it is optional and for people.
Can we comment out the hex line or not?
No. You're not commenting these out, you're uncommenting them.
Well, one of them was commented, one of them was not.
Oh, really?
Yeah, the second wasn't commented.
Show me.
It just looks like this.
Line 30.
No, go down.
Oh, where are we going?
Add name to device.
Line 30.
I see it.
So what was the first one? What was the first line number?
First was, I thought it was 30. First,
It's 933. So you're looking for lines 9 and lines 33 to uncomment. Both of them have to do with name. If you look at the first one, it's called name. If you look at the second one, the parameter it passes is that name again. It's also the gap advertising data complete local name. Someone playing Age of Empires?
Do we still have to do that thing with Yosemite where we go?
Actually, Sam or Sam? Did we update the boards for Yosemite?
Yes.
So it should work out of the gate, just drag and drop.
Okay.
Yep.
I have the same problem with Yosemite too.
Did you bring your own board?
Yes, I did.
So if you were having Yosemite problems and you brought your own board, please take your board to the nice gentleman in the back. He will update your board for you and give you one of our current lenders that does work.
Oh, thanks.
That patch is going to be rolled live at some point in the near future.
Oh, nice.
We just have to finish beta testing on it before we can release it. There's checkboxes we have to tick. But it works.
I tried some workarounds posted, but none of them worked for me.
The command line's the only one that actually works.
I tried that. I must have done something wrong.
All right, just go swap out your board in the back.
Oh, definitely check the change. There has to be unique, so you just change.
And make sure you change the name. You don't want it to be change me, especially if you have an iOS device. iOS, if you remember, has got this wonderful caching policy, and by wonderful I'm being totally sarcastic, where if you give an iOS device a name, it'll hold that name over multiple name changes of the device itself. So give it your name or give it something you'll recognize so that when you change the name, you can use it over the next couple iterations.
So in line 33, we're replacing device name with our name, or is that the?
You're uncommenting these two lines,
Okay.
and then right here on line 9, this thing that says change me and the comment that says change this,
Okay.
change the change me. Make it something else. Make it
Yep.
tobysmith@aol.com or something.
That's important. Yeah, click on it.
You're trying to do it.
I changed it. I'm just not seeing it.
Yeah, so you look at the code on your board. Your same board. Refresh. And so you're going to want to find the most powerful signal. Just put it right next to that because there's probably a bunch of noise on the boards. Right, so someone loaded your code without actually updating it. So what they do is try clicking on ones that are named high bar percentages that are right there. And one of those is going to wind up being your thing. So because it's so if you're that close, you should be something that's more 50 to 60 range. Yep. There you go. And if you go back out, it should update. See? That's the yeah. The developers that actually coded it now, they can change it. Great, so once it's connected to you close your save.
I don't know any changes there.
What's the name of the
Line 9 has to go.
Oh, I'm sorry, this is not your time. Sorry.
Should be.
How do I download the device? Because I don't see the device.
What app do you use?
When you compile,
Compile and I got the X down.
so if you have it plugged in, you should see
Yeah, I think that's a
as a disk drive right now. Is that right? Plugged into the right port? Or is that the display?
I guess you can.
Yeah, so this is more about your cell phone. Okay. Awesome. There, I'm gonna have you plug mine. Just 1 second. Yeah, plug this in. Yeah, what's up, guys?
Sorry, I wasn't here last month.
It's all good.
Do I need to nope, that would be.
That's not even the thing we're
I
going to
don't even need that at all. Alright, so I just need this.
Well, have you changed the stuff?
Yes, I need to stuff. And then just wait, download these hexagon.
That should show up on USB drive for Dragon from it too. Yeah. So you should see,
There we go, $40.
Oh, maybe you
I have to
don't
activate it, right, so you know, it's a virtual phone.
So drag and drop the file to the And when you do that, that's not actually a USB drive, it's a fake USB drive. So it's going to take it, it's a thing that shows a USB drive as soon as we hand it something, goes, and psych! Loads it onto the board, and if that window will close itself.
Download a copy of it.
Yeah, thank you.
What, yeah, the NRF toolbox is the thing.
You want the NRF master controller.
Put it original. Got it. I think this works.
That works? Cool, then let's trade this board out and try and get a different because this is mine.
Actually, I don't think my board's working either.
Really?
Yeah, I don't have like a fan.
You know, we did have a couple of bad ones last time that tossed back to the box.
Yeah, I got
Oh, hey, that's good.
Been doing that back.
Yeah. Oh, Windows. Also, once you get it working, just try changing the data. You'll see on the data line it's 0, 1, 2, 3, 4, 5. There's one above it that has different data. Try switching it out. Try changing the data. Try messing with it. See what you can get. So. No idea. Last week, right? Okay. Someone had a question. You had a question.
I did, but I take it back.
Okay, cool.
I retract my previous question.
Yeah, I think I haven't, but I don't believe.
Cool. That's what this understanding. So this is that board. You're good. Go and import that program. Can you jiggle the mouse around the computer? Sure. So you're finding out when it was up there? Yeah.
There it goes.
Yeah, that's exactly how it is. Who's got the cheapest Just buy things on sale for $49. So like I was gonna buy like a Galaxy 3 or something. It was like, I don't want I just need something fancy.
And you gave it that
Let's just try a copy and paste instead.
If you got coffee,
with cable problem.
I just have to. I like this one better than mine.
Yeah, it's my work phone.
Instead of saving people, just.
Alright, so has everyone got it? YouTube, coming to you. Nope. Okay.
How do you see
Ooh, that's a shit. This is an idea. What's your question?
I saw my device name, well, briefly, and then
Reset your board.
this is,
I was actually about to do the that is the base. I say, to be violated.
నాకు బాడీ వర్క్ వచ్చింది.
So there's a bug some of y'all are noticing. This bug is you'll see your device, you'll connect to it, and then if you back out, you won't see your device again. You can't connect back up to it.
Oh, sorry, it's just.
What that is actually a design feature. It is not a bug. I pared down the code so it'll fit onto a single slide, which means I omitted things like the disconnection callback routine. So if you disconnect from the device, it doesn't start advertising again. It just sits there and goes, well, I'm done. So right now you have to repower the device. If you look at any other example, you'll see the disconnection callback routine, and that's what, when you disconnect, starts advertising. GKs are not working. Let's just see if
Don't download this on so just wherever you can find it again.
Yeah.
You installed the serial.
VMware window. I'm running in the VMware.
Oh, that's true. Yes.
Now you have to hold up a reset button while you plug it in.
Yeah, like it might be too. So.
Go ahead and you know how you change that.
I should come back to
So what's that? So this happens.
much better. It's strange because last month
Yes,
USB 2 over here. I don't have USB 3. It's going to be BLE / serial.
File, so it's something $40
BLE device.
Beautiful.
Yeah, it works fine. It's like $40 here. It's like I don't have to buy a tab.
It should.
What were we saying?
Okay, cool.
Yeah, that was great.
It's a, what the thing is. It's like a bunch of mobile LG.
So with no plan for you. Alright. Yeah, what was that?
Until the.
I'm gonna go back and see if I can make this happen inside of the meeting. Just by going to the museum, okay.
See on the troubleshooter. Okay, so, line 9.
Okay. Well, if it fails, we'll bring the money.
Well, no, and then the other two, actually, like, say,
You can actually navigate.
Is there a separate Git patch?
Why do you need it? 2 seconds. Try right this is
oh, that doesn't matter. Okay, so, okay, so that's part of the
So, when you do it,
okay, so that's the same thing.
Yeah, I think. Yeah, we're
Yeah, but this is also my second school.
my question is, if we haven't been here last time. Go for it. How do I upload to the what? How do I upload it? To the device? It's a USB drive. You drag and drop. Yeah, I didn't see it. It should show up as embed. Cool. Talk to this man about installing the driver because he's going through the exact same problem. As long as you install the driver. There you go. Because it's not detecting that. And for Windows 0 configuration,
Same one?
I don't know. Oh, we got more lights. That's can be good and that can be bad. Did Evan Yep. Go ahead and open up the, just to make sure that.
Yeah. So has everyone figured out how to view their data, how to change their data and make sure it's their device? Raise your hand if you haven't. If you're having trouble, raise your hand. That was very responsive, so I'll give you a hand. We just, install it. It's because this device has a unique high speed rating. Alright, so if any of y'all are looking at like your device data, you'll see stuff like, for example, this guy, Bubba's Doohickey. I'm looking at his raw advertising data that he's shoving across, and what I'm seeing is a whole bunch of hex data down here at the bottom. That hex data is whatever characters he entered in his screen. Unfortunately, these apps do not display ASCII, they display hex. So if I said A, B, C, D, E, it would come across as 32, 33, 34, 35, because that's the numerical code for A, B, C, D, E. So just keep that in mind. If you're writing like this line,
Yeah, the numbers.
that's what I'm talking about. That's what
The one
it
above it is
is.
what I entered.
Right here?
Yeah.
Yes.
Okay.
So FF is the type that you're entering. Did you give her anything a value of 0, 9? Oh, what's your device name? It's probably motor. So if you look at the, if you go, you can find multiple websites that'll convert hex to ASCII. So you can try entering those strings of numbers in to double check your information. Also, fun fact, if you look at your COM port, so all of these boards have got a serial port that's displaying stuff out. It should be printing stuff if I remember correctly.
It's got an SPP or something?
Where did I put it?
Your Android?
Yeah. Oh, I did not. Never mind. That'll happen again. Cool. So that's how you view your advertising data. Any questions, anybody? Hopefully everyone got it.
Peripheral disconnected while being interrogated. It's usually when I'm right.
So make sure you're pulling down to rescan.
Yeah.
Also keep in mind what I said about needing to reset your board after each time you connect.
And then I find that it happens when I put alpha in the data, like A, B, C, D. So if I put numerics, it does.
In which data?
The advertising data.
Are you entering as X numbers or as characters?
As a character. So I find that if that character, it just puts it back over to. It puts it back over to.
Oh, wait, yeah.
No, I didn't. Yeah, or already jumped up.
Did we start with?
Alright. What's his name? It's all going? Yep. Ready to go. No problem. Right.
Okay, so I'm going to walk through the code real quick and then we're going to move on to GAT because we're running out of time. So this is what the code looks like if you were to open up your main.c. This is actually the entirety of the code you have. Again, the reason the disconnection callback isn't there is because it wouldn't fit on a single slide and I want it to fit on a single slide. So if you look at this, we've got several pieces of information here. The first bit is the change this data line. That's the line that you can shove 26 bytes or 26 characters of information onto. Because in C, every character is 8 bits, which is 1 byte. So you can shove 26 things in there.
What might those things be?
Text data for the most part. If you wanted to, you could say in 26 bytes, the first 3 bytes if I have, say, a magnometer, which has got, magnetometer, accelerometer, gyrometer, a light sensor, and a humidity sensor. This is actually what the TI sensor tag does. One of their things that they shove across gap is they take a byte, a byte, a byte, a byte, a byte. And so one's making like the first 5 bytes of their gap payload, and they just shove the value in from that sensor into it. And so if you look at their gap advertising data, it's just 5 bytes of randomly fluctuating stuff. But if you know that the first byte is magnetometer, the second byte is accelerometer, the third byte is gyrometer, then you can read that data and go, oh, hey, these are the values that it's broadcasting. Cool. And you never have to set up a connection. So in theory, anyone who walks by can read that data. They don't have to have passkeys. They don't have to take the time to establish a connection. They're just walking by and go, oh, hey, there's a thing with a UUID device number that I know is a sensor tag. I know that's a sensor tag. I want to read its gyro data. So that first byte is its gyro data. Cool, I know what the gyro at that point is.
These chips have a encryption coprocessor though, right?
I
I'm just wondering if you could encrypt that data using the coprocessor.
So you're using, I think it's an M4 is the board you've got. I don't know if it has an encryption coprocessor on it.
They're M0s.
M0s?
Yeah.
Probably not. But it probably has enough horsepower to do it though. Anyways, did that answer your question?
We're still in gap, right?
Yeah, we're still in gap. We're not in GAT. So this is all without a session, just broadcasting onto the ether for anyone to pick up on.
Okay, that corrected me because I thought gap was part of like some sort of handshaking.
It is. So the gap layer is used for multiple things. We're just using it to transfer data.
Okay.
It can also be used for the, hey, I see you, I want to connect to you. Here's a special GAT packet. Now you send me a thing back and we get a handshake going and then we've got a GAT connection.
Gotcha.
So if you want to get to GAT, you have to start a GAT. Even though technically there's a special way that if you've had a session, you say that you can resume a session, and complicated shenanigans, it's hidden by the stack. So anyways, that's 26 bytes. The first thing you do in all of your BLE code is you initialize things. This call happens before you call any other part of the BLE stack, because you have to initialize your device and do a couple of things under the covers to make sure it works. The next thing you do is you accumulate your advertising flags. In this case, that's the 3 bytes and 1 packet that you lose. So 2 bytes of overhead, 1 byte of data, that's 1 full packet. This one is saying that BR-EDR is not supported, that's traditional Bluetooth. It's saying that it is general discoverable, which means anyone in the room can take a look at it. And then it has another thing under it that says advertising connectable undirected. That should sound weird to you. GAT doesn't have to be connectable. It can be non-connectable and still work just fine. Connections are for GAT. So why did I make sure to add this? For all you iOS users out there, that light blue beam app won't show you the advertising data until you connect to it, because iOS. If you've got Android, you can easily set this as advertising non-connectable undirected, and it would work just fine because you don't establish a connection. But because of that bug in the iOS app, I had to make it connectable so that everyone can see their advertising data. So dead to rights, when you go to production or you want to make a thing, just doing GAP, it doesn't have to be connectable. It's usually non-connectable. Next section. This is where we're shoving 26 bytes of data. This data chunk gets shoved, where to go? So advertising data gets shoved right here into advertising data. We're flagging it as manufacturer specific because that's what everyone else does. Technically, you could also shove it to username or anything else you wanted to. It's just tradition, and at this point expected, if you want to be co-compatible with anyone, that if you have custom data, you shove it into manufacturer-specific data. Question?
If you wanted to change that data on the fly, like for an accelerometer,
Yeah.
what do you do?
There is a update value field that's part of the stack. You'll see it in the next example.
Okay.
I decided not to include it in this example because you usually wouldn't. But if you wanted to, we declared this as a value into the stack. There's an update value that's part of the stack call. So you can be like, hey, that thing, update it for me. And it's like, okay, got it. And it moves on. Last thing, start advertising. That is the last thing you call. It's kind of like the equivalent of BLE init. This is BLE finished initting. So BLE init sets up the hardware. You then set all your flags into the stack. You set up all your data, get your nice tower of cards built. And then this BLE start advertising, that's the super glue that you spray on it afterwards. You go, okay, it's not going to fall over if I start doing things. You can then modify it afterwards if you want. But init, set your stuff up, start advertising. That's the flow of the BLE API that we have. Questions? Sweet.
Could you show how you get the BLE library into the project?
It should be there.
Oh, it is in there. I'm just saying if I was doing my own project, how would I get the BLE live?
Oh, you go to new and instead of program, you hit library. It pulls up the search window and you search BLE_API. It just pulls up. Also, one other thing to note, this right here is an infinite for loop. That's because BLE is largely interrupt driven. This wait for event is a low power state that the chip will kick into. So, hey, nothing's happening. I'm going to snooze until a callback happens. Because all of BLE is callback based. And you'll see that in the next example where we set a callback for a write event. So when the write event happens, it wakes up and goes, oh, I got things to do. I'll go do that. And then when it's finished, that interrupt exits and goes back into sleep mode again. And that's why BLE is so low power, because you're constantly sleeping until something happens. Cool. And y'all been playing with it, I assume. Yeah? Awesome. We're going to go ahead and look at custom GAT now. So GAT, just to refresh your memory, is a hierarchy. The hierarchy on top is service. Every service can have characteristics. Characteristics always have a value. That value can be between 1 byte and 512 bytes, and they can have multiple descriptors. They don't have to have a descriptor, but they can have a bunch of them if you want to. These descriptors were initially intended by the Bluetooth specification guys to be a way to describe in English language what your characteristic is. In practice, no one uses them because everyone uses well-defined characteristics that have a UUID. So when you see a UUID of 2902, you go, oh, that's a health thermometer. I don't need a descriptor to tell me that. The UUID tells me that. Go away, descriptors. You take up space. So no one really uses them. If you want to, you could add a descriptor for every characteristic saying, hi, this is John's BLE heart rate monitor thing. This is attached to my pinky. But that same data, instead of being construed in like 30 characters and taking up 30 bytes of space, could be construed by using a UUID that matches the heart rate characteristic with a flag that says, oh, hey, I'm on his pinky. So that reduces it to 2 bytes of well-known UUID and 1 byte of flags for location. So why would you put 30 bytes when you can do it in 3? So no one uses descriptors is the point of that. Questions, thoughts, concerns?
Give me the output of the O string too.
Sorry about that. Let me put that back.
Is the standard UUID documented then? Is it like a documented standard or something you factor the things?
So everything has UUIDs. Every part that is well specified has a UUID that can be looked up on the SIG website. So if you go to developer.bluetooth.com, and then there'll be a little drop down that says like GAT UUIDs and GAP UUIDs and characteristic UUIDs and service UUIDs. Everything has a UUID. That said, that's mostly what we covered in the last class, was how to plug into well-known services and well-known, well-defined things. Most of this class, we're going to be like, and we're throwing that out the window and making our own. Everything will still have a UUID. We'll just assign it ourselves because maybe they don't have the athlete's foot tracker that we want. So we're going to make an athlete's foot tracker UUID and maybe make it closely resemble the health tracker or something like that. You know what I mean?
Wasn't that when you were telling us that if you want to get that your UUID published, it's big bucks or something?
Yeah, so that, I probably didn't explain that well. Your device has a UUID at a device level. At the device level, you got to pay big bucks to get a shortened version of it so you can piggyback off their thing. And it's mostly actually so other people recognize you. If you really want to, you don't need it. If you don't want to interact with anyone else, you don't have to. And lots of people do that. That shortened UUID is just easier to read. It gives you access to a couple dozen shortcuts. That's really the point. They all get expanded to a big UUID eventually. It's just the short ones are really handy to use. So, yeah. When you actually transmit across the air, it doesn't transmit a short one. It transmits a big one. It just takes that short one and it pins on the well-defined one saying, oh, you have a short one. Cool. The rest of you has to be this. Cool. Cool. So this is what we're going to set up today. We're going to set up a single service, and it's going to have two characteristics. One characteristic is going to be readable. The other characteristic is going to be writable. You could also set up one characteristic that is read and writable, but I thought that would be too easy and defeat the purpose. So we're going to have one of each. What we're going to do is we're going to write stuff to the writable one, and then the internal program is going to go, hey, I got stuff. I'm assigning it to the readable one. So that's where you'll see how to update a pre-existing thing, a pre-existing value with a new value. Because every time we write to it and write it correctly, we'll see a new one pop up. Any questions on this? The service UUID, we're going to use a short one, which is technically a it's illegal to do this. Not like in the law sense, but in like the spec sense. It's not kosher to do this, but I'm doing it anyways to save time, so I don't have stuff running off the screen constantly. So the service will be A000. The first readable characteristic will be A001. The writable characteristic will be A002. Remember those numbers. So go to this URL, the short one, not the long one, and import that just like you did the last program. Can everyone see that? It's a little bit low. Cool. Just going to take this opportunity to mention that the slides are up on the Meetup page. So if at any point you have any questions or I move too fast, you can grab the slides from there. I'll just redirect you to the Google Doc page. For later on, when we get into the Evothings apps, on those pages you're currently linking to, you'll see like a blurb of stuff above the code. That blurb of stuff has other links in it, one of which is to the Evothings code. So keep those tabs open.
What's going on? Yeah.
GATT?
Yeah.
Yep, we're currently on GATT. We've moved on.
Okay, because the other one's just gap on your screen.
So it does. Yeah, no, it's supposed to be GAT.
Okay.
I'll correct that later. The short link works, that's the point.
All right.
Do we need to connect before we compile this one?
No, don't connect before you compile it. Remember that name that you used on the last one, actually, especially if you have iOS, because they'll do name caching. It's there. Cool. And this new one, we're going to change the name again to that same name you had. Except this time, we're going to do more cool stuff. So you got the code imported? Spiffy.
I saw myself.
All right. Anyone still working on getting that code in? Cool. Moving on. So, do this! Change your device name. Change it to whatever you're using previously, or change it to something totally different. If you're using iOS, I recommend you keep the same name so that your name cache doesn't confuse you and you can't find your device. Yay, Apple. Then compile your code, load it onto the board. For iOS, use light blue again. For Android, use NRF Master Control Panel. Connect to your device this time. Unlike last time, do not disconnect. Once you're connected, stay connected. Go to the write characteristic, which was A002, and write to it. Try writing a single byte, 0 or 1, and see if the LED turns on or off. Cool. So make those LEDs blink.
Working? No, well, this seems to be working fine now, except it doesn't seem to be showing up here.
So did you change your name in the code? Did you compile it?
Yeah.
Did you load it on your board? Did you reset your board? Try resetting it. Now try rescanning it.
That's all done.
అక్కడ ఫైల్ ఎగిరిపోతుంది సార్
Like put your phone next to you and flip it sideways. Which would be closest to 0 is decibels. So it looks like Bubba's doohickey is coming in strongest right next to us.
Oh, you have to know. It's the same value. So you want to change.
That is still there, right?
So it's reading the same value.
Was it working before? Were you able to
It worked a couple of times and then I started getting
Have you tried resetting your board?
it's the power cycle.
Honestly, I would say.
So we're going to go to A002. See that? Right away. We're going
I downloaded this one.
Try doing a reset.
yeah, there's a much newer version. Yeah, like a much newer version of this one. Let me show you what it should look like. It should look like this. Or like to connect to something that reset works.
email LED click
This characteristic.
Maybe it's a problem. Maybe it's just an issue.
Okay.
characteristic
I don't know.
Just try killing turning off Bluetooth.
Oh, you
Get out of it. There's a lot of just like turning it on and off, but sometimes
well, yeah.
yeah, I saw the yeah, I saw the sticker. Now it's all grayed out, so that's why I'm thinking it might be. Hey, no, not it's connected but not on it. Yeah, it's fine. Okay. So you're good.
So hopefully that
Ah, there we go. That LED just came on. Okay. So 3 0 1 0.
So what I'm thinking is
0 1 2. Okay. That's the LED we'll check.
Yeah, I guess
No, you said the right surrounding. Oh, I'm using it. Yeah, I'm just trying to figure out how to write. I'm looking at. I'm actually looking for something else. Okay, just saying maybe LED turned on. I'm just trying to figure out. He's using the NRF master control panel. Okay, you're using labeling because you have an iOS device, or is that Android?
It's Android.
That's Android. Cool.
What's this master control? You said right 1 or 0, but didn't try saying.
All right, I'll go over it. Let me pull it up real quick.
Oh, we're not going that far yet?
Oh no, you're supposed to be, but I mean, it is a little bit more complicated than I remember it being. So let me pull it up. So I'm going to do this with y'all.
Oh, we're compiled. Yes.
I've got a slightly different device with a brighter LED. I'm going to use that. Is that the tiny BLE? It's quite bright, isn't it? Is that the C tiny BLE? Yes, sir. Can a device have more than one service? Yes. You can have any number of services you want. I'm just doing one because it was easier. Yeah, you can definitely have multiple services and multiple characteristics of each service. That's what I'm trying to figure out. Okay, let's say I got the decay working. Yeah, what $4 do I use?
Those are the ones that came with it, right?
Cool.
These are $70.
Those are the ones that there are little chips in there. Like
With the 24L1. Oh, you know you might want to do.
There's like a strip of 4 chips in there. And 51822.
Oh, the A122s are cheaper.
So, if anyone is having trouble, I'm going to walk through how to write to the device. So, this is the code that I wrote. If you notice right here, I changed my name to Austin. Code's over here on this side. App's over there on that side. So the code right here, God darn, that's small.
Big to me.
All right, there you go. So I changed it to Austin, which is my name. So if you were to scan right now, okay, you have to.
Oh, because it's actually that's how
There we go. So I found my device. Does everyone see that? I've got a device name Austin. What I'm going to do is I'm going to connect to that device by clicking on the connect button. I'm going to connect.
Just looks smaller too. It's kind of weird.
It's actually just going to open up this screen.
I'm like, cool that stuff.
We're also tracking you. We advertised your device name.
Funny enough. That will actually be possible soon.
How did you get that?
Well, if you turn it sideways, it'll display that.
I think if you
That's an Android thing.
No?
Ah, there we go. So connect. There we go. So these are the three services you'll see on every device. That 1800 and 1801 are included by default on every device I show up. What we're interested in is this third service right here. And if you notice that A0000 right here, that's what we set up earlier as the service identifier. So if you look back over here at the code, right up here at the top, custom service UUID, A000. There it is. So I'm going to open up that service, and sure enough, it has 2 characteristics, unknown characteristic 1 and unknown characteristic 2. If you look at their UUIDs, you're going to see the A001 and the A002. I'm noticing a pattern. Also, you asked about what gets appended to the end of the UUID in case it's a 2-byte, 2-byte UUID. This string. This whole bunch of stuff in, that's the extra stuff that is the Bluetooth SIG official blob. So if we remember, the first one is read, the second one is write. In case you forgot, it says it right here, read and write. I'm going to hook up to my write characteristic. I'm also going to subscribe to my read characteristic. So this little up button right here on my right, I'm going to click on that. I'm going to send 1 byte. So UAT8. The value is going to be, this LED is on right now, so I'm going to invert it. So I'm going to send 1, and I'll turn it off. And for some reason, you have to give it a name. I don't know why. It's a thing on the app, not on yours. Yours is different and better. Okay. So I'm going to hit save it. I'm going to hit OK. It went off.
I'll be back in just a second.
On this board, much like last week's, the LEDs are inverted, so 0 is on, 1 is off. So now if I were to click on write again, and I write 0 this time, I select byte or UAT8. I put UAT8 because it takes care of stuff. I'm going to give a name of T2, save it so I can quickly access it, and I'm going to write it, and my light just came back on.
Seems like if you put 0, it is on. Anything else, it's off.
Okay.
Like A or at least
if you send 1 byte of data across, because of the way I wrote the code, 1 byte of data will get written to the LED. No bytes of data will not get written to the LED. So yes, you're right. If you write 1 byte, 0 will turn it on. Anything else will turn it. If you write multiple bytes, if you look at your terminal, it'll print out to your terminal. And I'll probably come back to the beginning versus terminal.
still the light. It's still the
I just turned on to across the room. Want to see how far I can go. So that's how that works. For those of you who've forgotten how to use the terminal, I'm going to open that up real quick. If y'all remember, there's a really awesome program called CoolTerm. So CoolTerm, I like it because it'll figure out where things are connected.
Windows on?
Windows or Mac. It works on both. I'm going to make sure it's connected to the right port, which it seems like it's done. Hit connect. And if I actually I can't restart that, so let me write a characteristic. What is it off right now? It's on. So I need to write a 1 to it. So I'll upload, and I'm going to use a 1, and I'm going to hit OK. And sure enough, it says LED on. Because in the code, I added a little bit that when it toggles, it'll print out the state that it's in.
I can use coding.
That's more complicated than yeah, you can better grab it. So if you're on PC, you go to Device Manager and look at your ports. Yeah, now look at ports. Oh, you need to install the serial.
Click on the embed device 0.
So config, that's what you want.
Yeah.
So if you get this money,
Oh, we can
you click on serial.
Yeah, it's done to get this to you.
Yeah. So if you want to see what's being written right into your device, there's two forms. In one form, if you write a single byte, you'll toggle the LED. If you write more than 1 byte, in this case up to 10 bytes, it'll print that out to the terminal. So try writing multiple bytes to it with the terminal open and see what you get.
Is that the easy thing? I didn't even read it. Cool, sir.
So it's right there.
So, I believe, so that's just a program you have to download. Yeah, I think it's just zero. Is, are you familiar with I personally have Could you show them where to go back to the Is the art still playing nice? No, it's starting to act up again?
Data zero is a bit or a byte?
It's download error. The same thing? Yeah.
What I said about caching systems.
It sounds like it's
There are term not today.
but that's so
Oh, yeah. Oh, so zero is.
Oh, we got it. So something was.
I'm in the right spot, Arch BLE.
Yeah, no.
Just refresh points. It's probably just there.
That doesn't usually work for me. Yes. I'll plug it to unplug the for you. Yeah. So I'm wondering if it's it's an OS. It might be an OS thing or it might be hopefully it's not a keyboard or hardware. But yeah, I would before you actually shut it down or before it boots up again, make sure it's disconnected. I think sometimes you shut it down. Hopefully that will do as well. It's fine. I just think it's back in the check.
Not disconnected. Yes, check on on.
It's fine. Like I said, that's why I was just like, I'm like, why is that not doing it?
Yeah, can't wait to get this. I feel like I was here a few months ago.
Oh, read is just the 5 word. Ford is probably listening to
That's essentially all that's happening.
Well, I should be able to.
I got putty out, but I how did you get it to show up on the screen? Well, it's not showing anything to the device. If there's anything other than this.
Yeah.
I mean, it did when I just did it. This is why I was actually there was zero. I was kind of just assuming it's what it is.
I'm having no luck.
Once someone else connects.
I just set the cool term.
Doesn't show up.
I just what settings for the cool term. I'm not getting anything.
If you use cool term, it'll automatically detect which port it's on. So you just hit connect and it'll connect.
If you have your driver.
Yeah, there's that. Yeah, but he should have it because he had the issue with the board because he showed up, so he had to install the rotor serial.
Oh, well, there's something.
Good? Hey, you're getting stuff. Cool. Now try writing multiple things to it.
Byte array.
Yeah, do a byte array and type in like 5 values. And then send it out and see it print out. So you installed the little serial driver?
Yeah, have you luck?
Well,
Yeah, you got through. I'm curious what the issue was.
what's
I blame my own.
So right off
Okay, well, that's working.
So you have to reset it, basically. Is that
Oh no, I just know that there's a thing in there that when I reset it, print something. So it's back to us. You know what? And you install the new serial driver?
What they tell you to do is what they're side.
I tilted the switch so you see it. Okay, so that is not the right one. Go up to the top. Sorry, Windows serial driver. Nope. Yeah. That's 600 page. A whole bunch of stuff. Yeah.
Right check.
Were they not gonna glow there? That's why I'm surprised. That's a Mac issue.
Okay, so slight addendum. I kind of lied. My bad. The LED on-off thing, that's still in my private repo, not in the public one. My fault.
Okay.
If you want it, I can show you how to add it. You add it by going down into the right callback, and there's one little line right here that I added. This line, if I can get that thing to go away, essentially says if data 0 equals 0, print the LED is on. If data 0 equals 1, print that the LED is off. That's all it is. So if you want to add it, you can. Not terribly important. You can also validate that it's working by, instead of writing 1 byte of data, try writing like 6 or 7 bytes of data. And you'll see that print out on the command line. Just open up your terminal and write like 6 or 7 bytes. Okay.
Well, no, like if you write.
Anywho, so I'm going to go over the code.
And then you can just look at that.
Good? You look like you've got slight confusion eyes.
It's like,
Yeah.
The driver for the serial port.
Yeah, Mac or Windows? You don't need it. Yeah, if you use CoolTerm, it's not the default one. You have to go down to like USB modem. Yeah. Should be like the last one. So try that and then click reset on the board and you'll see it spit stuff out. Anyhow, gonna take a look at the code because we're getting up there in time. So this is what the code looks like. There's going to be 2 slides worth of code that I'm going to go over with you. In the main file, this is the first part. These little bits are the important ones. These are the UUIDs. The UUIDs are A00 for the service, and then A001 and A002 for the characteristics. The device name and the device UUID. You changed your device name, but if any of you tried looking, like say over here at the device UUID, how do I do that? Should be FF somewhere in here.
Right at the very beginning, there's a UUID that's real long.
Yeah, so if you look at your device name, like over here in Austin, service complete list UUID is 0xFFFF. That's where it comes from. So you can advertise the UUID services that you'll have on your device using that little section right there. Technically, I should have put A00 here, and then if I had other services, back to your question of having multiple services, this is where you'd list out all the services you have in your device. That's because as part of your advertising bit, you're saying, hey, by the way, I've got these services in here. If you're interested, ping me and I'll give you more information. I manipulated this to say FFFF because I wanted to. You could just as easily change that to any other UUID you wanted. So like say you paid for that UUID, I definitely shove it in here. And be like, hey, this is my thing. If anyone sees this being advertised, it's me. And so that'd be one way to scan for your device in a crowded room. This is characteristic 1, these 2 lines. I define a 10-byte array of uint8s, that is the read value, and I initialize it to 0. I should probably switch this back so you all can see. Sorry about that. So C1 is readable, C2 is writable. If you look at them, they're just 10-byte arrays. I take the value and I shove it in down here. So you'll see read value and write value. They'll be repeated down here in the lines just under them again. So like right here, I declare read value. Right here, I pass in read value, and I pass in the size of it and the size of it. That's max size and min size respectively. I do it again for write value. Here I declare write value. I then make a characteristic. The characteristic has got a UUID from up top, the write value pointer, size of it, et cetera, et cetera. Let me go back. The final thing you do is you take your services and you roll them together. You take your characteristics and you roll them together into a service. So this first thing right here is an array that says, hey, here are the pointers to my characteristic values. And then the next line under it says, cool, I'm going to make a service out of these characteristics. And so I pass it the array of characteristic values and the UUID for the service that I want it to have. Make sense? We build it from the bottom up. So if you wanted to have multiple services per se, here's where you'd build it. You would add another service tag up here, so it'd be comma second service tag. You would then down here essentially clone this, create characteristics for your new service, and then add this service. And that's how you'd create multiple ones. If you wanted to add more characteristics to this existing service, you'd do it by taking these 2 lines, copying them, pasting them, changing the name, and adding it here. That's all it is. It's a whole lot of text, but it's actually really simple at its core. The next section is the write callback. This is the part that was changing things for us. So remember when I said you go into a deep sleep mode and when you write something to it, a callback happens? In your main loop, you register that callback. In the case of gap, we'd have a disconnection callback. We also have one on here. So if you look at your code, you'll see disconnection callback. It's like 3 lines. We also register the write callback. So that's what I'm doing right here, registering the write callback. Next, we're going to take a look at the write callback itself. Every time that a write happens to the device, this function is called. And it's because I registered it right up here. First section, it checks to see what is being written. Every single thing that is written has a UUID and a handle. Handles are kind of like indexes within an array. So if I were to write a whole bunch of stuff, a handle would be like the index into that, saying, oh, this is the first, second, or third thing written. Those handles actually have unique things in them that I can use to check against the declared things. And so that first line there, right there, that says if char handle equals right char handle, it's just checking to make sure, oh, hey, this is the thing that I think it is. Does that make sense? Because I could, in this case, I only have one right characteristic. So there's only one thing it can be. But if I had 3 right characteristics, like right char 1, right char 2, right char 3, I'd make sure to check, hey, the thing that's coming in, is it right char 1, right char 2, or right char 3? If it's right char 1, do this. If it's right char 2, do this. If it's right char 3, do this. So this is that if statement that determines what is being written to. Very important when you have multiple characteristics. The rest of this is just handling the data. It's really all it is. It's a printf. It's a very ugly printf.
The last line is pretty important.
Oh, at the very bottom? Yeah, that's why it gets its own little box. So yeah, that's all this does is it prints the data coming in and back out. And as you can see, I actually included the LED toggle message here. Sorry that I didn't make it into y'all's code. The last value, or the last line, updates the characteristic on the read value. So everything ahead of that was just, hey, we've got a write. Okay, let's do stuff with it. This last value goes, let's update that read characteristic, so broadcast back out the thing that was just written in. So I believe you had the question about how to update. You had the question about how to update characteristics. This is how you do it. So this is how you do it. Characteristic values. For in gap, there's an equivalent that instead of saying characteristic value, it's say like gap value. Just an API call.
When we first started, we were using gap in broadcasting.
Yes.
So, and then this thing is using gap too when you're not connected to
No, this is strictly gap.
Well, it uses gap for the broadcast part, right? Like on disconnect, you re-enable gap.
Yes. That's the best way to think about it. So when you set up your name service, when you set your name,
advertising.
Right. It's setting up the advertising packet. So yes, to get to GAT, you have to go through GAT.
Yeah.
As soon as you connect to it, you enter a GAT session to trade that data back and forth. So that gap level thing, if you look at light blue or you look at the NRF master control panel, before you hit that connect button, you can only see like 3 pieces of vague information, which is the UUID, the name, and maybe the services that are inside of it.
Manufacturer's data that we were sending before.
Right, the manufacturer's data in that case. Although, yeah. We had to do that little hack for iOS, didn't we?
So, I mean, I guess the reason I'm asking is if I wanted to have a beacon kind of thing that's using GAT to transmit some data, I could connect to it with GAT, update the data, and then disconnect from GAT, and it would be broadcasting.
So in that case, it wouldn't be you're connecting to a beacon. You're connecting to a service that sits beside the beacon on the same device, because beacons technically do not have GAP. They're GAP only.
Right.
But yeah, you can do that.
But I'd be using it like a dead drop or something to I could update something in that device.
That actually already exists in the guise of firmware over the air, also known as FOTA, F-O-T-A. And that's essentially what it does. It has a firmware update service that sits there. You connect to it, and it's essentially just a UART port with a little bit of spiffiness on top of it, where you go, hey, I got a thing, and it goes, okay, cool. And you shove it across to it, and it goes, cool, updating the rest of this. And so you can do the same thing very easily to update characteristics or broadcast. Any other questions? Yeah.
So does advertising automatically turn off as soon as you start a GAT session, or is that something?
Yes. When you enter a sessioned connection, the advertising is terminated.
Does that mean I can't operate multiple GAT sessions simultaneously?
You can. So that gets into a slightly deeper question. Depending on what chip you use, it'll support different things. Nordic, for example, which is this chip that we have, they have several different soft devices, which is essentially like little RTOS that runs inside the chip. Different versions of their RTOS support different things. One version supports being able to be a master and talk to things. The other version supports being a device only, which is what these all are. And there's another version that supports switching back and forth between those. It's totally feasible to, by the spec, to have multiple things running at once, but that requires you to have the master console. Device version is one-to-one. The master version is like a star topology where you can actually do one-to-many. Unfortunately, this does not support that yet. So while the BLE spec supports it, and the Nordic Soft Device 1.30 supports it, I haven't gotten around to integrating 1.30 because it takes a lot of effort. I'm working on it. So yes, by spec it's possible. By this stacking.
Is there a way for the device to reject being connected?
Yes. Remember that flag I was talking about earlier when I said I made this connectable so that iOS will work, but actually it should be non-connectable?
Okay.
You don't?
But, well, what I mean is reject being connected with certain, but okay with certain other. You know, like not a I don't connect ever, but like for example, I program my device and someone in the room connects to it, I can get my thing done, right?
Oh, so you mean like filtered based on what's incoming?
Is there like an on-connect method where you can check parameters of the device you're connecting to, that's connecting to you, and then say, nope, I accepted that connection?
So yes and no. Much like there's an on disconnect and an on write callback and on read callback, there's also a on connection callback. You cannot reject it prior to the connection being made. You have to let them connect, but you can have it set so that the first thing you do after you connect is go, you look sketchy, I'm gonna go ahead and terminate this now. So you can put like a gate guard there at the very beginning in that callback if you wanted to.
So you'd be able to find out if like the MAC address of the device is talking to you.
Very
If it
easy.
doesn't match some list, you can just disconnect it to that.
There's actually this power company in the Netherlands, I think it was, 2 or 3 years ago that was doing that. And you'd see their guys rolling around with a tablet updating the firmware in their poles. And some hacker just sat there and sniffed it and figured out, oh, all of them have the same MAC address. Turns out it was a whitelist based on MAC addresses. So yes, you can do that. That form of security is kind of terrible because it's security by obscurity, which is always hacked. But yeah, you can totally do it. And doing that with something else is definitely a great way to go.
So could you just have the device pair that? So if you have 2 devices, obviously with something small, it's hard to get that 6-digit code, but isn't pairing a way to essentially ensure that you have the central peripheral matched together?
So the concept of pairing is not so much a BLE as it is a traditional Bluetooth one.
Sure.
You do have the concept of previous existing state and the ability to essentially say, hey, we had this handshake. I'm going to hang on to this handshake that we did. So if you ping me later on, we can get started much quicker. It's kind of like saying, I know who you are, you're not sketchy, you just pass right on through. There is a version of that, which is why some of you probably noticed when you were trying to reconnect, if you disconnected and reconnected again, it might happen quicker than when you updated the firmware and then tried to connect. Because that little bit was there in the stack already, but that's hidden from you as a user. That's just a stack thing. Well, back to where I was.
So if you wanted a security method, might be that when you connect, you have 10 seconds to send in a key or it kicks you off.
Yeah, you can totally do that.
Or to answer a challenge response, when polling a value, returning that value encrypted the right way, or else you get rejected in 10 seconds.
So security is a whole other field apart from this that I'm just gonna be like, make sure you ask your certified security professional and let them receive total liability.
Yeah.
I accept enough. So that said, take a minute, play with the GAT, see if you can make it send different stuff across, see if you can implement those callbacks you're thinking about doing for on connect to inspect the device. Take a look at the API because it's built into the compiler. If you click on something and hold, it'll spring up a little pop-up menu and you can click on the documentation and work through things. Am I lying? I am totally lying. We've got 10 minutes. Don't play with it at home. I'm going to run you real quick through something else. This is the point in the slides where I say we switch over to Evothings and play with it. There is a slight problem in that we have 10 minutes of time left, and Deb writes we should probably be packing up and moving out so the angry redhead outside doesn't come in and kick us out. But if anyone is willing to lend me their laptop that is not a corporate laptop to let me play with Evothings and show you really quick, that'd be awesome. Because I found out a wonderful bug this morning where my corporate laptop locks down my firewall and I can't actually use Evothings outside the corporate network. So if anyone has a machine with a mini display port or HDMI cable, I can show you Evothings really quick. Rocket sauce. You have it installed?
Yeah.
Awesome. So Evothings is a wonderful little platform that if you looked at the emails I sent out, you'd be able to download. It runs as an executable. Is it in your downloads folder?
It's running right there.
Yeah, but I want to show them how to open it.
It's in downloads. Yeah.
Cool. I'm going to close that out real quick. So if I go to downloads, Evothings, here's the thing you downloaded. He unzipped it. Inside of it, there is a wonderful little executable. You double click it and it'll open up. This works the exact same, by the way, on Windows, Mac, and Linux. It's wonderful, cross-platform and awesome. You have the latest version, which is 1.1.3. I'm going to take my tablet. I'm going to switch this over so you can see the tablet view real quick. So I'm going to take my tablet. Cool. Top left, I've got the Evothings client application I downloaded from my app store. I'm going to click that and open it up. I need to exit what I was doing previously. I'm going to click on the Scan for Workbench button, which is going to scan the local network. Okay, there's a bunch of people using Evothings. What's the name of your Mac?
Yeah, Kevin MacBook Pro.
Kevin's MacBook Pro local. There you go. So I'm going to click on that, and I'm connected. If I come back over here, I can run any number of the existing applications. So like, I'm going to click on BLE Scan, because I like it. And there it is. It's now running on my tablet. It's magical. Through the magic of wireless, UDP, and TCP, it shoves a JavaScript file from this sandbox to that sandbox. It makes for really quick prototyping. So I'm going to click Start Scan. And this is going to list all the devices around me. So I see JCope back there in the corner. I see your device right here. I see SGW1. I see my device. And it's running. I'm going to now go over here to the BLE Scan code. So if you missed that, I clicked on code. Brings me to this. There's an app.js and an index.html. These two files, along with some library stuff that you don't have to worry about, are what make up your application. So if I open up, oh, I didn't want to open that. What editor do you have on here?
I think Sublime Text Wrangler.
You've got Sublime?
No, I don't have that one now.
Of course it is.
Sorry.
It's all good. Sublime's my fave. Okay, so this is the index.html file. I'm going to scroll down somewhere inside of it and put something. Okay, so let's alter, scroll back up to the top. I'm going to add a paragraph underneath the start button, underneath the stop button. I'm just going to add a paragraph here. And this paragraph is going to say, Austin was here. Wow, because I'm a child inside. So if you notice on the left, I just added that code. I'm now going to save it in 3, 2, 1, save. This thing on the bottom here now said loading. As soon as I saved it, it was dynamically reloaded over to the tablet. You can now see Austin was here, mwahaha, up there on the screen. That's running in real time. As soon as I make a change, it gets loaded and is in play. This makes for rapid turnaround time for developing apps that just, it's mind-blowing when you're coming from the embedded world. It's amazing. I really like it.
It's not over BLE, right?
No, it's not, unfortunately. It's over Wi-Fi. The way it actually works is it opens up a TCP connection and just goes, and here's a file. And it goes, cool, I'll run that.
Got it. Yeah, I realized that because that Mac's too old to have BLE.
Anyways, you can look at their existing applications and modify them if you want to. Just like I just modified that index.html, I'm now going to modify, open with the app.js. So I open that up. You don't have shortcut keys. This is not doing good highlighting. So let's say we change something in here. What do you all want to change?
Text Wrangler instead of text edit.
You have text wrangler?
Yeah, you have the other thing open in text wrangler.
There we go. So I'm gonna go down, looking for something, anything that has something cool in it that I can modify.
Does the Evothings workbench require Node to be installed on a Mac?
No, it should just be prepackaged alongside it.
When he double clicks it, he gets some.
We'll try to install something.
When he copied over Evothings desktop thing, but when he tries to run it, he just gets some kind of console window thing.
Oh, leave it in that folder. I tried moving it over to
Don't remove it from that folder.
Yeah.
That thing it comes in, this is not an installable application. This is a standalone application. So that zip file that it unzips from, it unzips everything into a folder. Leave it in that folder.
Should I re-download it?
Or just move it back or re-unzip it, whichever you prefer. Okay, so I'm going to go to a handy dandy GitHub page that happens to be my GitHub page and pull down an example for y'all to check out. I happen to make 2 examples to pair with that embedded code that we did earlier. So I'm currently running GAT, so I'm going to go ahead and use that. Just GAT. And I want to download this. You're not going to let me download, are you? Right there it is. So I'm going to download the zip. Awesome, that's done downloading. Go into downloads. By the way, I'm going to make this easier for y'all to download later. I just didn't have time today to zip it up into a handy dandy side thing. So, custom GAT example. If you look inside here, I've got the app.js, index.html, libs, and UI. And so what I'm going to do is go to Evothings, take this index.html, drop it, and that's how you add programs to it. You don't have to put them anywhere special. You just drag and drop the index.html into here, and it adds the program for you. I'm now going to run this, and it's going to go over yonder. Shazam magic. And I should be able to toggle the LED on my board. Except that it's still scanning because I changed my name. Does anyone have Change Me still as their board name? Of course not. I do. All right, and this is a good example to open up and change the internal stuff. So I'm going to open with Text Wrangler. And I'm going to change my device name to Austin. So I've got a list of those, right?
Is that case sensitive? Your uppercase. Is that case sensitive?
It is going to be case sensitive. I did that, didn't I?
I think so.
Okay, so I'm going to save it. Come on, save. Going to run it. Ah, there we go. It's connecting. It's connected. Now, if I toggle my LED, I press the button and it toggles.
Can you show the HTML?
Yeah, just one sec. My point is, I made an app in about an hour that lets me toggle an LED. I know it sounds ridiculous, but it's really awesome. I'm very proud of it.
I couldn't see that screen over there. But where did you get your app from?
So I downloaded it from my GitHub page. I'm going to put a link on the thing later and actually wrap it up so you can download it really easy.
Okay.
I then pulled the index.html to this screen right here. which created this bar. I then ran the code, which runs it on my tablet for me once it's connected.
So you can just drag and drop on top of the workbench.
Just the index.html. And now I'm running code. There's another really cool thing here called tools. So looking over here, there's a tools thing. I click on that, it opens up this window. I'm gonna clear my log. As I'm toggling things, I've got console.log messages, which is just a JavaScript construct telling me that I'm toggling my LED. That's all it is. So if you wanted to see the code for it, I'd go back over here to the workbench, click on code, and I'm going to take a look at app.js because that's actually where the magic is. So if I look at app.js, open it with Text Wrangler, here's the code. In this case, up top, I've got my device name. I changed it to Austin. Y'all will change it to your device name, and it'll connect. Down in here, there's a thing called start scan, which starts scanning, as the name suggests. Connect to device, read all services, get hex data, and then here's my toggle function. This toggle function, I take my index.html, also loaded in here. I missed tab divers. Text Wrangler. Come on. So if I look at my index.html, this button, where'd you go? This button right here, with an ID of toggle, when I click on it, calls app.toggle. Y'all can't see that for the life here. And I can't make it any better. Anyways, it calls app.toggle. Over here in my app.js folder, there's a function called app.toggle. Guess what gets called when you press the button? This function. This function, what it does is it tries to read a characteristic that is A001. In case y'all don't remember, that's the read characteristic. It then, through a process of jumbled JavaScript, because it's not my native language, goes, hey, that read characteristic, is it a 0 or a 1? If it's a 0, write a 1 to the right characteristic. If it's a 1, write a 0 to the right characteristic. That's all that does. So it reads it, checks it. Right here, there's a function called write characteristic. Guess what it does? It writes a characteristic. It's writing to A002, which is the right characteristic UUID we gave it. And it writes the value that I toggled up here. That's it. Straight JavaScript. It's toggling an LED over Bluetooth. If you know your way around the web front end or how to use JavaScript, you're going to love this thing. If you don't know your way around JavaScript, you're still going to love this thing because it's a lot faster than anything else I've ever prototyped with. I'm going to send an email out to the group that will have links to both the slides and prepackaged versions of the zip file for the GAT and GAT Evothings examples, because I actually created examples to pair with your embed code that you have. I'm sorry that we didn't have time to get to it today, guys. But yeah. That said, please fill out the feedback form. We are currently looking for suggestions for the rest of the meetups for the rest of the year. So we've got BLE almost taken care of. We're probably going to do one more around going to production, and then probably spend a couple hours just hacking. So if you've got some cool BLE ideas, next month we're just going to have like an hour and a half of straight hack time. So come back, we'll have boards, we'll work on whatever you want to work on, and then after that, I'm going to plan it out and make awesome.
Now I vote for HTTP, internet access, and talking to web services and things like that.
Cool. Fill it out on the form, which is on the bottom of the meetup page. I'm going to do it by numbers. I'm going to be all scientific and do it by numbers.
Do it by numbers, yeah, exactly.
Right, if y'all borrow boards from us, please turn them in the back. And yeah, hope y'all enjoyed.
Thank you. Thank you.